Next in this video series, I'll demonstrate how to machine pockets, and I'll now switch to working in metric because up until now I've been working in inch. So first, I'll start by coding these two open pockets, which are 2 millimeters deep. Then I'll program the larger 5 millimeter deep pocket. How the tool enters a pocket is critical since 100% of the cutter is engaged in the cut unless the pocket is part of an existing cavity, as can be the case with cast parts. As with circular pockets, the tool can plunge into the material, or helix in, or ramp in, or feed into a pre-drilled hole. Since the first two pockets are open on one end, hence the term open pocket, I'll position the tool to the cut depth in the air near the pocket, then feed into the material. During the first cut into any pocket, the feed rate will be slower than when cutting the remainder of the pocket because 100% of the cutter is engaged in the cut. The cutter will also be pulled towards one side of the pocket since it is climb milling on one side and conventional on the other. Once the first pass is completed, the remainder of the pocket should be climb milled unless the setup is not rigid enough. When machining pockets, the smallest internal radii will determine the maximum cutter diameter for the finished pass. For the two open pockets, the 1 millimeter radius will not influence the cutter diameter because any cutter which is smaller than the pocket width of 7 millimeters can be programmed to cut these. The 3.5 millimeter radius of these pockets will limit the cutter size to 7 millimeters or less. The larger central pocket has 5 millimeter and 2.5 millimeter radii. For this pocket, the 2.5 millimeter radius is limiting the cutter diameter to 5 millimeters or less for the finished pass. Ideally, the cutter radius should be smaller than any internal radii to be cut. When the cutter radius is the same as the internal part radius, in this case 2.5 millimeters, the cutter may start to chatter when cutting the corners due to the small hesitation in the corner as the cutter changes direction. To avoid chatter, a smaller radius cutter is used and the feed rate may need to be sped up so the cut load is increased, thereby reducing the chance of chatter. When a smaller diameter cutter cannot be used, the corners can be pre-drilled. In the next video, I'll demonstrate how to code the open pockets.